Hi, and welcome to the 35th webinar in 12D's Industry Solutions webinar series. My name is Lisa Stewart, and I'm the Marketing and Communications Coordinator here at 12D Solutions. Our Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll keep running these webinars regularly and recording them for posting on our YouTube channel with links through our website. Our first 34 webinars from this Industry Solutions series, as well as the 40 webinars from our training series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way. We'll put some instructions on the screen. We'll answer as many as possible of those throughout the webinar, and at the end I'll read out some of your questions to the presenter if there's time. Today's webinar, IFC and Civil BIM, will be presented by our co-founder and managing director, Dr. Lee Gregory, who has 37 years of experience in the civil software industry. Using the International Open BIM interchange format, IFCs, all the data in 12D model, including attributes, superstrings, tins, drainage and sewer networks, and trimeshes, can be written out for seamless transfer to other BIM packages. Simultaneously, 12D Model can read in IFC files from architecture and other IFC supporting packages, and uses trimeshes to capture the data. And by using the power of 12D Model, any localized data can be quickly transformed so that it accurately fits in with the civil data in real-world coordinates such as MGA. Over to you, Lee.
Thank you, Lisa. Good afternoon, everyone. Today I'll be going through the technical information on IFCs, which is needed for everyone to understand them and what they're about and how they interact with BIM. But first, I'm just going to mention, have a quick mention of our Innovation Awards and the 12D Technical Forum, which is being held this year. So the Innovation Awards, this is one for all of you people to actually win some money. So they're now open and they'll be closing at the end of this month. There's cash and training prizes and trophies. There's a number of different sections that you can go into: design and visualization, survey and construction, the three waters, the customization, and banishing the drafting demon. So you can see there's prizes for each of those. Basically, for more information, go to our website, which you can actually get the registration forms and things there, and the entries will close at the end of this month. And teams can enter, and you can enter more than once. So there's no problem with having multiple entries in different sections, or even the same entry may apply to each section. And so basically, yep, there's up to about 17,000 Australian dollars worth of cash, training, trophies, and certificates. So certainly get your entries in, because it's towards the end of by the end of this month, so you can get some of that money. Now, our conference, which is no longer called actually just a conference, although I've got to hold a picture there. It's also now our technical forum. We've realized it's more than just a conference. It's jam-packed with other things, talking about current versions, talking about the version we're going to release at the technical forum. And so that's what's going to be now called. Here's a collection from beautiful people who attended once before. Basically, there'll be talks by both industry people and ourselves, and from 12D Model and 12D Synergy people. We have the Birds of a Feather training sessions. There's 4 of those. That's where we break up and do specialist areas, one on design, one for survey, one for 3 waters, and one for 12D Synergy. And so a lot of those are almost training, going through in great detail because we've got just the audience in that area. So they're very, very important for everyone to really learn and ask questions. We have technical talks on both 12D Model 12 and the coming 12D Model 14, which again will be released to people at the conference. You'll be able to, if you attend the conference, you'll be able to do the technical preview version so you can start playing with 12D Model 14, which will be released about 1 month after the conference. There'll be also technical talks on 12D Synergy. There's the welcome event on the Monday evening, the conference dinner, which is on the welcome event's on the Sunday evening, the conference dinner is on the Monday night, and the Innovation Awards, which are at the conference dinner. And we also have an exhibition area where in the breaks, there's very companies to go and have a talk to about things, and we also have stands, so you can talk to any of our people, our support people, about different aspects of 12D Model and or 12D Synergy. So yes, basically it's Sunday 29th, Monday the 30th and Tuesday the 31st of July. It's again at the Brisbane Convention Exhibition Centre. It's $800 plus GST for the 3 days, which includes welcome event and the conference dinner. But you can register for just 1 day or 2 days or any of the things on their own. Again, go to our website to register, and we do take credit card payments as well. Right, so just those two things for you, the Innovation Awards and the 12D Technical Forum, which is coming up in July. Back to our topic proper. What I'm going to do is go through the concepts and structure of the Industry Foundation classes, or what's known as IFCs. They're important for you to know because you need to know what can be done or what cannot be done with IFCs, how they're structured and so on, so you can talk sensibly to people. And I'll try and make it as easy as possible to understand. I'm happy to take any questions and follow up things later on. As far as 12D Solutions, we're a member of buildingSMART, and they're the group that look after the IFC definitions. I'll come back to that. We're also a founding member of the Open BIM Alliance for interchange between software packages with IFCs. We're involved in the buildingSMART international conferences, committees, expert panels, especially what's called the IFC Infra Room, which is defining the future IFCs for our model setup information delivery manual. I'll come back a little bit more what's in that later. IFC alignment, IFC roads, IFC rail, IFC tunnels, and IFC bridges. So we are involved in looking at the definitions that are coming for all these things. I also personally attend the buildingSMART international conferences, and I've just returned from the one that was held in Paris at the end of last month. So I've been to ones to Singapore, Korea, London, and the ones in Paris, and that's where we've been defining all these things for the future infrastructure with IFCs. Again, I'll mention more of that later in this presentation. So today I'm going to talk about Open BIM and Industry Foundation classes and where it's coming from, and then general concepts in IFCs so you can understand the structure and a little bit about them. I'll then also demonstrate reading and writing some data using 12D model 12C1M. In that case there though, I'll also give you some information of where there's some other demonstrations you can look at. So I'll just demonstrate there a few things and I'll read in some data from other packages. I'll also then talk about what's missing for infrastructure in what's called IFC2x, the version that everyone's now using at the moment. So that'll include IFC alignment 1.1, IFC 4.1 that's coming out, and also then IFC 5. Right, so let's get started into it proper. This slide I've used quite a few times. What on earth is BIM or digital engineering? And it all seems to depend on who you're talking to and so on. But it has come about so people can really interchange data and without using proprietary formats. That's where it all came from. And to date, most of it's been on buildings and structures. And we'll talk about that, about how does it work for civil. But why are people into it? Well, just here in Australia, the Queensland government has officially announced it has a building information modelling draft policy and principles, which came out in February last year. And inside it, it said they were going to use Open BIM. So that's why we're going to talk today about what is Open BIM. And that's coming from what is defined by buildingSMART. That's why buildingSMART's so important and why I've been going to those things. But it's basically a non-proprietary open standard format. And that's what this IFCs are all about. So the government in Queensland is saying that's where we're going and everything is going to have to use it. They're using also the NATSPEC National BIM Guides for infrastructure projects. And what is NATSPEC's an Australian organisation, and inside there it just talks about what deliverables, what things you're going to have, but it says the Industry Foundation classes or IFCs. That's what IFC is, Industry Foundation classes, and the model view definition. And the model view definition is just which things we're looking at. There's different model view definitions saying, I want only this particular information and so on. So basically that's where the Queensland government is saying, yes, it's got to be IFCs. They're also saying it needs to be PDFs, so you're getting away from any proprietary plot formats. and also E57s for point cloud data. But that's at different topics. buildingSMART, it's an international organisation which is supposed to improve and exchange of information between software applications used in the construction industry, and they develop and look after these industry foundation classes. And basically it's just a neutral and open specification for transferring data between software packages. NATSPEC, that's an Australian organisation which has a whole number of companies or organisations actually more involved with it, putting out things to Australia that standards and things to follow. So basically, in simple terms, BIM is really all about sharing and collaboration, exchanging of data, using open file formats, and in particular, the IFC format as far as it is applicable, because some things it doesn't cover, but you should then be using other published formats. And it's also vendor neutral, so you're not being locked into a particular package. Now, what are IFCs? Well, if you go to the buildingSMART website, it starts talking, this is where all the information about IFCs are. So let's say it's the IFCs, the open and neutral data format for open BIM. So when people talk about open BIM, they're saying transferring data using IFCs. And if you click on their wiki page, it says the IFC represents a data model structure for sharing construction and facility management data across various applications used in the building domain. So good, nice and general. It says the data model is an object-orientated data model based on class definitions representing the things, elements, processes, shapes, etc. that are used by software applications during a construction or facility management project. So it's not just physical objects, it could be processes and other things. And very important, it can have lots of metadata or attributes. And for a lot of people, they're not interested in what the things look like. They just want that attribute data to go into other systems, like things that looking after you, or the data after the thing has been constructed. It's also then a neutral and open specification that is not controlled by a single vendor or group of vendors. And that's the very important thing about it, is that it's open to everybody. Now, there's then if you go in there and get the definition, you have the industry foundation class definition, and this is for IFC2x. Now what this is, these are the versions. They use the word, they use 2x3 because in some things you can't have 2.3. So this is version 2.3. Now this has been around for a number of years, and it's the probably most widely one that's available. Most people at the moment are writing data out in the IFC2x3 format. There are other ones, IFC4 and IFC 4.1 and coming IFC5, and I'll discuss those. But basically the IFC2x3 is what most packages now can read and write. Now if you click on what there are in there is things called entities. So these are bits of information that goes into the file, and there's 653 of these entities. So they describe all sorts of things, and they've got all sorts of names like IFC action request, IFC actor, IFC alarm type, and so on. But there's the ones that we are particularly use for objects, 3D objects, are IFC elements. So all those, there's different types of entities, which you'll see some of them, or they'll be used. It's the ones that are called elements that are particularly important to us when we're trying to do 3D geometry. So basically, if you looked in there, what is an IFC element? It says it's a generalization of all components that make up an AEC product. So these elements can be logically contained by spatial structure elements that constitutes a certain level with a project structure hierarchy. Example, site, building, story, or space. Friggin' hell, what's all that about? And I'll come back and go through those things and say, well, what on earth are we talking about there? It also talks about then property set user definitions. So they have these things called property sets, and I'll come back to those. And they also have geometry use definitions. So an element is supposed to be then really for a thing inside a site, building, story, or space. but it also can have attributes or property sets, and it then has geometry. Most of the things we think about only have geometry, but it's not. Geometry is only optional. You don't have to have geometry to have something in an IFC file. So an IFC element can have geometry, property sets, which are basically like 12D attributes, and a spatial structure. Now, the IFC geometry has a thing called a geometric curve set. That's made up of points and lines and arcs. So basically things like we have in our strings. Also has a faceted B representation. So what the hell's that? That's something that's made up of faces in plan. So basically a trimesh. So it can handle trimeshes. It also can have swept solids. So things like our extrudes, where you take a cross section and extrude it along a geometric curve set, that actually gives you a what they call a swept solid. So it can be solid, it can be a profile, you can have rectangular profiles or circular profiles or arbitrary profiles, and you sweep them along a string, and that's what they call extrusions, the general ones. Now, what on earth is an IFC property set? And this is very important. It's just the name to a set of attributes. So you can have attributes just like you can have them inside 12D model. They can be hierarchical, but when you define a set of them and you say what they all are, they have to have a name. So we have string attributes at the top level which don't have a name. What you really need is your attributes have to be in, say, groups, and you would use that group to go out as a name for the property sets. So basically, though, it can have a hierarchy of them, so just like we can have. And there are very special things called P sets. They're a very special attribute property set which is defined totally by the IFC consortium, and so it says exactly what the names of things are in this P set, what the values are, and what the definition is. And for most of the elements that we're going to see, they then can have a P set that goes with it. So that's all well defined in advance. But in general, when you talk about property sets, they're just like your attributes. They can be whatever. You can have any names you want and any type of value. So if someone's asking you to give you information, they need to define all that sort of thing for you. They need to tell you what the attributes are going to be called and what their values are and what they actually describe. So that's what property sets are. So basically just think of them like 12D model string attributes, and basically we send our 12D model attributes across to these property sets. Spatial structure. Now this is an interesting one, and you can see why IFCs really have come from the building world, because you can give things multiple spatial structures, but you have a structure, you can have an IFC site, and then inside you have an IFC building, and then you can have an IFC building story, and then an IFC space inside that. So everything's supposed to be given this spatial structure. So yep, it's all very good, but I'm not certain if too many of our road projects fit into being called a building or a story or an IFC space. So yes, they could fit in an IFC site, but the rest of the spatial structure for civil at the moment is a little bit vague and really does not exist there. But you need to know about spatial structure, but most of our users at the moment just put out everything as IFC site because it doesn't really fit into a building, a story, or a story. What the IFC space is all about, that's really for inside buildings where instead of having a really good representation, a perfect representation, it's just like a block model, so you can work out, say, the volume of a room and things like that. So you need that to go into, say, facilities management systems. So you tend to draw up things and just approximate the room by a couple of rectangles, and that's your IFC space. So it's not a real physical object, it's sort of like an area. It's an area. So basically, because the site, building, story, and space don't necessarily apply for our sort of work with civil, it's mainly just IFC site. It's about the only thing we'd use at this stage. But yeah, IFC's 2x3 spatial structure is not very applicable to civil BIM. Now, what different types of elements are there? Well, basically, as we said earlier on, it's an object-oriented thing, this IFC, so it's built up in a hierarchy. And so things are defined at root level, and then under root you have object definition and so on, and down to then you have your IFC elements. And then you've got your building elements, your electrical elements, and so on. So it's really these IFC elements, they're the ones that we can actually see and what they do. And if we expand that out a bit, this is all that we really have. You've got an IFC beam, a proxy element, IFC column, covering wall, down to IFC window. There's a distribution element and a flow element, but electrical, and that's it. So when you look at the definite elements, you can say, well, there's not too much there that applies necessarily to a road. So this is where, what on earth do we do in that circumstance? You know, there's nothing in there for an alignment. There's nothing in there for a tin and so on, or just an arbitrary trimesh. But there's one of those elements is called a IFC building element proxy. And it's just basically a general element. So if it doesn't fit into any of those other categories, hey, you can make it thing of IFC building element proxy. So that is what's used for a lot of things if they just can't fit into that category. As I say, you look at that IFC building element category and it is very restricted when it starts coming to talking about roads and things like that. What's this hierarchy then all about? And then what they call inheritance, that if we're talking about, we'll look at IFC building proxy, is basically it's inherited from root. And so you always have IFC root. And in the definition of IFC root, and if you look into the actual IFC file, it says on there that basically for IFC root, it's got always has to have 4 things. A global ID, which is basically just a unique ID number, which is a way of calculating it. An owner history, which can point to information about who owns it and things. There's optionally a label, a name, and think of that like a string name, because those global IDs are just crazy numbers. It's hard to even imagine what they mean, but you can have a name. So you could use like your tin name and a string name, and then an extra bit of text for a description. The name and description are optional. But so basically, everything in this case here has to have those 4 things. Then under that is the object definition, and it doesn't have any extra information. There's then an IFC object, so this is the hierarchy of getting down to what we want, and from that there's a thing called an object type, which again is just a label. So there's a thing inside when you have a IFC building element proxy, it will have an object type. It then has placement, it's a product, and it's got inside it an object placement and a representation. Now, what placement means is just where in the hell you're going to stick the thing. So if this is something like a trimesh, you might then move it or position it somewhere and plonk it there. So it may be something like that to place it. Again, it's optional. And then the representation. Well, the representation is the geometry. And you can see that's optional. But for most of our objects, we will have a representation. So that's where everything comes in there. You have to have placement and then a representation. Then you finally get down to the element part of it. And again, there's a tag, which again is just an identifier, which is optional. And then finally, the building element itself. There's the next level. And finally, the building element proxy. And it actually can have another value, which is construction type, which is enumeration. So anything that's an IFC building proxy basically has all those bits of information I mentioned there, starting with global ID, owner history, name, description, object type, object placement, representation, tag, and composition type. And they're well-defined names that it has. So when you have an IFC element, it always has that information. Where it says it's optional, in various files like what they call a step format, which I won't scare you by showing you one, where they have $1, it means that's an optional bit of information. So $, means we're not going to have anything in there, just so you have the correct number of fields. So basically, they're the sorts of information that every element has. In this case, I've done building proxy, whereas say door or might have some other information that potentially goes with it. Now, our 12D objects, what on earth do they go out to? Well, superstrings, we put them out as IFC building element proxy because there's no other thing in there for it. In its geometry, we use the geometry curve set if it's just a straight string. If the superstring is a rectangular pipe, then we put it out with an IFC rectangular hollow profile definition. So it comes out as a pipe. Or if it's a rectangular pipe, if it's a circular pipe, we use the geometry IFC circle hollow profile definition, and we basically are pushing that down the geometric curve set. So we can actually put our superstrings out, including whether they're rectangular or circular. The property sets, which you can attach to these things, what happens, all our string attributes go out as IFC property sets. So that's what happens to these string attributes. The global ID that it has to have, that's just calculated at writing time. So at the moment, there's a way of calculating it unique in space and time. We calculate when we write it out. And for the name, that always has to be there, well, it's optional, but it can be there, we use the 12D string name. So basically a superstring can go out, its string attributes can go out, and we also can have the string name going out. So all that information goes out as an IFC building proxy. A super alignment. Well, there's no such thing as an alignment string in IFC2x. So to put a super alignment out, what we have to do is basically break it up into a superstring of segments, and then it goes out in IFC building element proxy, just like the superstring. And again, it's just a geometric curve set made up of segments, and it could actually have a rectangular or circular definition. The super alignment string attributes, again, we put them out as IFC property sets. The global ID we calculate at writing time, and the super alignment name goes out into the name. So when we write out these things, the string name is always available. And as I said, there is no alignment element in IFC2x. Trimeshes, they will go out to IFC building element proxy. In this case, the geometry, we put them out as what's called faceted B reps, where each of the facets is a triangle. So it's a special case of the faceted B rep. Any I missed there. Any of the Trimesh attributes can go out as IFC property sets. The global ID is calculated at the writing time. You can see I've missed a cut and paste here. And the Trimesh name will go out as the name. The drainage strings. Now, there were special things called IFC distribution flow element. And so this is for things like networks, electrical or drainage nets and things. And what happens is, as an IFC distribution flow element, the next level for pipes, we put them out as an IFC flow segment. So we break it up into separate pipes and pits, but they're all put together in this one, put together as the IFC distribution flow element. So for a pipe, again, the geometry, we can have circular pipes as IFC circle hollow profile definition. The reason why it's a IFC circle hollow profile definition, because then we can have a wall thickness as opposed to the other one for the superstring. Or it could have a rectangular hollow profile definition. So we can put the geometry out for a pipe. The pipe attributes go out as IFC property sets, and the pipe name goes out to the name. And for pits or maintenance holes, they go out as IFC flow storage devices. And again, the geometry can be circular pits can go out with the circular hollow, and rectangular pits as rectangular hollows. And the pit attributes go out as IFC property sets, and the pit name goes out as the name. What we've found, although we're doing these things inside 12D model, we're then finding some packages can't necessarily read these elements. Solibri has no trouble with reading in a IFC distribution flow element, but we have seen some problems with Revit and Navisworks where they can only read part of these things. Unfortunately, Revit and Navisworks don't read the things the same way. So we have ticks on our writer to allow us for those sorts of cases if the package does not satisfy an IFC distribution flow element. And in that case, we just write everything out as those general proxy elements. Now a tin, there's no tin, so it has to go out as a ifcBuildingElementProxy. The geometry, we set it out as a faceted B-rep, just like a trimesh. The tin attributes go out as IFC property sets, and the tin name goes out. There's only one problem here, though. It's just going out at this faceted B-rep representation, so there's nothing in there to say, hey, it's a tin and it can't go under itself. So we're getting the data across, but there's nothing there for a proper tin. And I'll talk to you about that, why that's coming in a future IFC. So yes, we can put out tins, but they're just going out almost like the same sort of idea as a trimesh. So inside 12D model, what can we actually do? We can read and write in 12D model C1M. There's a reader and writer for IFC2x and then there's an option in there called IFC properties, which actually will allow you to look at some more of that information I've been describing. So it's held there in the file, so you can just look at it to see what's going on. So I'll actually demonstrate some of these things to you, but as I say, 12D model 12, C1M, it actually can read and write the step format. So basically, I'll just show you that now. I've just fire up version 12, C1M. What I've done is I've actually got a project here which is based on Barwin, which we all know and love. And what I've got in here, I've got the a tin. I've also got a road and some various trimeshes and things, an alignment string, some cross sections, and some ordinary superstrings. So that's the sort of information. So we're just going to write that out to IFCs. So I'm just going to go in, it's under BIM export. And the export writer, I'll pick the views I'm going to write out. In this case, the IFC drains as an IFC system. I can write that out as that because I know we can read it back in, so I can leave that, don't have to do anything else. It goes out as it is. I can export attributes, but you don't have to do that if you want to. This output tins as IFC site, that's necessary if you go into one of the AutoCAD products or I can't read it. But basically, I'll just then give it a file name and write out the data. To read it back in again, under BIM import, there's an express reader. So in that case, the file I just wrote was webinar IFC. And what I'm actually going to do, I've got a choice here. As I read the data in, I'm going to split into different entities, or basically as different elements. So we can sort of see what elements are in there. And I'll give the name webinar for the prefix of the models. You don't have to split it out into different models. They can all come into the one model. And what we can do is we can make the string name, in this case, the instance name. That's the name that comes from the object. So basically, when we read it in, the string names will come back as string names. The tin name will come back as the name of the tin. But there are other things you can do there. There's other choices you can make. Default color, just beginning of thing, and we'll read it in. Right, so if we actually add this data on, I think I called it webinar, and everything's basically IFC building proxy because I forgot to pick particular on the IFC system, but anyway. So there's the data. I want to see it the same way. So what I've done is I have written out a view position. So I've just picked that to get the same spot. So the data seems to be there. You'll notice here though, some of it seems darker. Now I've done that in purpose to show you that what that often means is the item has been, say, written out as a one-sided, and it's the wrong way. That thinks the bottom is the top and the top is the bottom. And so we've got something to fix that up inside 12D called flip faces of the Trimesh. And we'll just see what that actually does. So if I pick the terrain out here and we flip it, now it's gone the other way, so it sort of looks okay. In version 14, there's one that does a whole model of this. Since we discovered it often happens, you want to flip the data around. So it's more or less now looking what you'd expect it to be. So we've written that data out, but what have we actually got back in? Well, before I get rid of it here, I'll just go into, I should have left it out there. There's another one called IFC properties. And what this is, if the IFC file is still here and we pick on something, it actually runs through the file and then picks out that information we're discussing that goes with it. So this thing has a global ID, and there's the global ID number, which is so unique in time and space, but I hate to be trying to refer to it very often. The only history is #13, it's a line number in the file, it's got more information. The name was just called Brown, since it didn't have any other name. And so this is sort of information for the object type. We just put in the word triangulation. The object placement, again, that refers to line #41 inside the file, and the representation is line 43628. So if I really looked at that IFC file and went down to that line there, I won't scare you by looking at it, that will give you all the triangles that make up the IFC proxy element. So that's the information that's there. If I look at it with, say, things like string information, not certain what attributes we put in this one. I haven't gone this far. So what's happened here, we've brought in a thing as a 12D model. We've been putting some information in there about things. So we've actually added some of these in here, some extra information. So we put in there the file name it's come from, the entity name, a global ID, so you can access these sorts of things as attributes. And a bit about what a spatial structure is, which we've discussed, and the actual spatial structure name. So we've put some of those automatically in as elements, and I didn't have any other things to bring across. No, that's not true. Under 12D model, here I've got the information that went with the tin, but it didn't come back as a tin. It's come back as a trimesh, basically, but these are all the attributes that were for that tin. Right, so basically the data can come out and it's come back in, but you'd have to re-triangulate it if you wanted a tin, because we just don't know when the general thing comes in like that what it is. What you could possibly do, because we wrote there as the object type, we put in the word triangulation, we could do a post-process to automatically fix that up. Right, so that's writing some data out to IFC2x from 12D and then reading it back in. So you can see it wasn't all that difficult to do. Can that data be read into another package? Well, we can if we just go and open up that area where we did it. It was called webinar, I believe I called it. If I just double click on that, I've actually got that link to Solibri. So when I double click on IFC, it'll pick up the Solibri package and load it in. It'll just take a second. It was just loading it on the other screen. So that's loaded the webinar. So if I click on model, there's the data there in Solibri. And it's got that information. You see there's a 12D model So that's the attributes we put across. Now, you can actually get your attributes to go out into separate property sets and give them names by just having them grouped as attributes inside 12D model. So that's all possible, but in this case, we just put them all out under 12D model. So all your attributes can go over there and you can have your own named property sets. It's quite easy to do. So yeah, the data's all read into another package. So it's not just us who can read our IFC, Solibri can as well. Now reading other things in, because this is, we obviously made it ourselves, so there's probably a good chance it actually works. So we can look at a couple of other examples. So I've got a couple of examples here from these ones actually came from ArchiCAD. So just to see what we get, I'll just read one in. Now what I'll do is, actually I'll just drag and drop it onto 12D view, C1M. If you have 12D view, C1M on your system, basically if you drag and drop an IFC file onto the 12D viewer, on the 12D view, it'll open up the IFC Express reader. It's the same sort of thing we were using in 12D model proper. The same sorts of things we can do in there. And so I'll read this into the IFC reader that's inside 12D view C1M. So it's finished the file. And what's happened here is we broke it up into the different elements. So you said there's beams, there's building element proxies, columns. So even in this file, there's things that are building element proxy because there was nothing in IFCs to send them out to. So there obviously wasn't any wind phones. But basically, if we just add it all on, so that's what there were the things there that came as building proxy. So that's come in, and just like we did before in the 12D view, there is also the IFC properties, so we can pick on something. Oops, so they're on there. And again, we can have a look and see exactly what it was inside that element. So this one was actually a turbine, and it has again this name, global ID. It's been given name Turbine Huey, French, I think. One thing you'll notice though that's interesting is for civil, like our work, we usually have a string name. We always usually have a name to put in there, and often they're unique names so you can identify something. Where in the building world, they just often don't have that same sort of thing to go by. Anyway, so that data's come in quite happily, read into the 12D viewer. So I'll do another example with a bigger building. The second one I've got, which is another ArchiCAD example. Again, I'll just drop it onto my 12D view icon. So I'll just bring it up here again. So I've dropped it on there, so it is just automatically put into there. I'm just changing this so you don't get the rendering color. So I'll read in this file. So it's read in. Well, again, it's got things like beams and stuff like that in it, and things you sort of expect in a building, but you know, say not too many of our civil things. So it's got some proxy elements too. Obviously things it didn't fit into. It's got roofs, it's got slabs, it's got stair flights. So we'll just add all of it in. So basically we've got a building. There was a thing there I'll take out as IFC space because it's not really a building, it's just like an area. So that's our building there. While I'm here, I may as well have some fun. Since I'm in the viewer, I've got that there. So what I might do to just show what the data's like, we'll just add all the data to a plan view. And inside the viewer, I'll start a section view. and just see what happens when we section through this sort of data. So I'll add on all the data. If we go down to profile, 2 points, one of our old favourites. And we'll start profiling through from there to there. Oops, not looking so good there. I'll just go and change the thing to one as one. It's probably a bit of a skinny building, so we'll bring him across so it goes that way a little bit. And yeah, so there we are, sectioning through our building. If I took off the IFC space, so as you can see, the trimeshes all section quite happily. And give you a nice example of what the thing looks like. Right, so in that case there, we've read in some data. In those ones from other packages, and any examples we get, we try and test out to see if they come in quite well. So there we're talking about IFC2x, which is the older thing. If you want to see some more demonstrations of that sort of thing, there was a webinar that John also got on BIM workflows, and he reads in other data as well. He reads in FBX files and other files, and he gave that on the 21st of March, so it's not that long ago. And if you go to our YouTube site, under the industry webinars, his is there, the BIM workflow industry webinar series. And it's well worth you playing that one because it'll go through that, a lot more examples on it, where I was just looking at some IFC examples of data and getting them across. Also, just some general information on BIM. You can go to our website. There's a BIM and Digital Engineering section. And now this is new that we're just setting up on our 12D Model Forum a section where we'll start putting a lot more examples and people can put information about how they've been going and things that some packages do and others can't, to do with IFC2x. And as far as training, we are actually now putting on some courses. So the first ones, there's going to be one in Auckland on the 11th of April, so that's next week, and one in Brisbane on the 18th of April, which will go through how to construct BIM and do things. So before I go on to the civil, more stuff, just to let you know there's things you can do already in C1M right today. Now, I'm just going to talk now about, it's all very good. Everything we've seen there has really been what we call vertical BIM. It's all really been developed for buildings, building sites, and you can see that even from that spatial structure where it goes site, building, story. That really says they're talking about buildings. So it's often not suitable for long, longitudinal infrastructure projects, which I would call horizontal or civil BIM. There's a lot of other restrictions, and people seem to think they're restrictions of IFCs, but sometimes they're more restriction of the software, not some, and I'll point out some of those things. So our big challenge is, what does civil BIM need? We've got to be able to handle large coordinates. Everything we do is in something like MGA. So you've got to be able to handle it, and for large distances, might be for 20 or 30 kilometres. So they've got to be large and long. We need arcs, which is actually a helix. When we talk about our arcs, they're actually a helix because they're, when you look out from the top, they're an arc in plan. They're not a 3D circle. We need strings with and without diameters and attributes, and your attributes on strings, vertices, and segments. So important these days. You need your drainage, sewer pits, and pipes. You need tins, which can be hundreds of millions of points. You need trimeshes. You need alignments. One of the big things you need alignments for is just what we call linear referencing. In buildings, people use a grid. It's just a rectangular grid. That's their referencing. For most civil works, we use linear referencing where it's chainage offset. So you have an alignment, which may only be a 2D alignment, and you have a distance down there called chainage and an offset. And that's how we place most things in our world. So you need this linear referencing. You need transitions. So you've got spirals, cubic parabolas, and so on. They're essential because they're in all road design. You need names for strings. And luckily in Australia, most of us have used names of things since 1980. And you need a published format that's available to everybody. So they're the things we're going to need. You also need people who understand all these sorts of things, including coordinate systems and so on. So we'll now just go and see, well, can Open BIM actually be civil? Can it actually do all these things? The good thing is that buildingSMART recognised the deficiencies in IFC2x. They say, yes, it's all very nice, but it was really for vertical buildings. Everything we want is not there. You saw, though, when I wrote our data out to an IFC2x file, most of it went across and came back in, even though a tin went out and came back as something else. So you can get the shapes and things across, but you might want to know more. So there's two things they've looked at. One is called the IFC Model Setup Information Delivery Manual, and that's all about how do we work with a large federated model when you don't just have a small building site of maybe over a kilometre. So that's a special project they've done, which we've been involved on, to look how you work for large sites. The other thing they've done is they're looking at international groups, looking at IFC for road, rail, bridges, tunnels, and so on. So these are all underway because they realise there's deficiencies. So what's this model setup idea all about? It's coordinating data from lots of sites. So basically you have a small site can fit in a kilometre square, but with a large site it could go over tens, even hundreds of kilometres. So basically like even a railway or a road, you know, you've got, yes, there's some station one's a smaller area that you might do in some sort of architectural package. Maybe for a bridge, could be in a structures package, but somehow you've got to bring them all together and make them all make sense. Because often those architectural packages use 0, 0 on the left-hand corner. Well, that sort of doesn't work when you're trying to bring it into a large system. You'll have errors of tens of meters. So basically what they've come up with in the version 4.1, is they do have information there about map projections, height datums and things that you use for the whole site, and also giving you the information if you have 2D helmet parameters for each small set, so you can use a 2D or helmet to bring it into our FGA coordinates. But that should be done for each individual site. And there's potentially a Z shift, because most of us say use a height datum like HD, but on building sites they just often measure from the floor level. So there's possibly a Z shift comes in as well. And so the idea is that you have for each little small site, you have its own special helmet and Z shift to bring it into our consolidated, say, FGA coordinates. So if that's all set up properly, in the future you should be able to bring this data together and not get all your problems when architectural packages just can't work on large areas and in FGA coordinates. So that's one thing that the IFC people have been looking at. The other thing they've done is they've recognised there's problems with roads, rails, tunnels and bridges and so on. So they've set up groups to look at this, and I was over there in Paris where they were discussing all these things. So they've got the road design, there's a huge group looking at that, the railway design, the big Chinese group. So they've got different people involved in each one. What they realised though, one common element to all of them was an alignment. You need an alignment so you could do linear referencing. So what they did is the IFC alignment is going to be the first priority, so that could be used for everyone, because everyone in all these things said everything's done by linear referencing to an alignment string. That's how most things are set up. So what's happened with the IFCs is you have down IFC4, which has come out, even though not many people have it. They then looked at that this thing was defined to be called IFC Alignment 1.0 and IFC Alignment 1.1. And they all going to be part of an overall architecture, going to be part of IFC 4.1, which is coming out towards the end of the year. And then I'm making sure that there was anything that was common between all these different areas, they use the same terminology. And IFC for rail, road, bridge and tunnel, they're scheduled for coming out in IFC 5, which I think say 2020. So basically, they have been looking at it. They realise there are some deficiencies. Now, 12D have been involved in this. We've had a project with the main roads from Queensland, TMR, called the IFC Alignment Project. And so I was the project coordinator. We were the software suppliers. Queensland Transport Main Roads, where I say a client, and Jim Plume from the University of New South Wales as part of buildingSMART also was involved with it. And what alignment 1.0 was, that you just have an alignment string which has independent horizontal and vertical geometry, which is exactly what we all know as an alignment, where you could just have horizontal segments of straights, arcs. In this case, they allowed one transition type, which was the natural clothoid, and vertical segments, which can be straight, arcs, or parabolas, and a 3D approximation to the alignment. The idea of that was if someone can't read the alignment in, they could at least read in the 3D approximation, which is what we have to do now when we write out an alignment from 12D into IFC2x3. So that was that project. And in 12D model 14, we actually wrote out and could read in the alignment 1.0. So our alignment strings, the horizontal could go out quite happily, the vertical could go out quite happily, and the 3D alignment, we could write it out as a 3D, basically a 3D string as well, where we gave an interval. So we actually did that, and I presented that in Korea, Jeju, in September 2016. So we were able to read and write alignment 1.0. Next, though, was alignment 1.1, and it actually had more transition types, so for rail and things like that, and it also had tins inside it. So basically, again, with the main roads project, we had for alignment 1.1, and this again was version 14. This is actually from last year, where all this data, which is the data I showed you before, this time though, the tins could go out to an IFC tin, and the alignment could go out to an IFC alignment. So when we read it back in, we actually got a tin and we got an alignment. So basically, we could write out now strings, alignments, and tins to an IFC alignment 1.1 file. And I actually had that at London last year. We presented that, and what we've been doing is working with groups and interchanging these files to make sure that all these vendors that we can read and write our own packages. A lot of the work I've been doing there is a group in Spain. They seem to be the most advanced. And luckily, when I was in Paris last week, the week before, I was able to meet up with these people so we could continue the work. So in this case here, we've written out that data in alignment 1.1 and then read it back in. As I say, it comes back in as just as we expect. So can horizontal BIM and open BIM, can it apply to civil? Well, let's look at all those criteria that we discussed. Large coordinates. Can you have, say, eastings and northings? That's already handled by IFC2x3. If people are having trouble with large coordinates, it's the software, not the IFC format. So there's no problem there. Can it handle large and long horizontal projects? Well, you can have eastings and northings in it, so you can already do that now. But if you want to mix people with packages who don't understand large coordinates, say architectural packages, and how to bring them together, IFC 4.1 with the model setup, information delivery manual structure, that will take care of that. So when 4.1 comes out, you should be able to bring those sets together from disparate packages. The helix for arcs, yep, IFC 4.1, which has alignment 1.1 in it, that actually will be covered. Strings with diameters, that's already handled, because we've already done that, writing things out. Attributes on strings, vertices, and segments. They only have attributes, really, what we call string attributes. It's a bit like GIS, where you've just got the attributes for the whole object. So if you're going to use a lot of that data like that, you need to also give 12DA or a 12D XML file, because only attributes on strings is covered in the IFC 4.1 definition. Drainage, sewer pits and pipes, they're already handled. We're doing that today. Tins for surfaces, IFC 4.1. Alignment actually also includes tins, which we've already got running. It does not, though, handle super tins. Again, you need something like 12DA or 12D XML for that. Remember, 12DA, 12D XML, it is a published standard. It's a text format that anyone can read and write. So it is following the whole idea of open BIM, where you're using a format that everyone's got access to. So there is no problems with that. And what we're discovering, and people are realizing that, yes, you can ask for a BIM model, but what Queensland Main Road say is doing is they say, yes, but we also want the 12DA or 12DXML for the project for all the things that aren't in a BIM IFC model. So into the future, specialized data, an open format like 12DA or 12DXML will still be really an open BIM. Alignment, independent, horizontal, vertical, and so on. Yep, that's all in IFC 4.1 alignment. Transitions. I have to check some things there because they do have special rail transitions, but I haven't seen the New South Wales one in there. And even the Queensland, or the ones we use for roads, is not quite the full clothoid. So I will check that, but for our work, we're able to write those out as special cases into the IFC 4.1 definition so we can get them back exactly. But at this stage, I fear in the full definitions, the New South Wales cubic parabola is not there because that's different to a spiral cubic parabola. Names and code for strings, well, we've been doing that since 1980, so there is, as we saw, there's every IFC object has a name so it can go across. A published format, yep, IFCs and 12DA, 12XML. For any missing data, that's all published and free of charge. So you can see all those steps. IFC 4.1, which is supposed to be out the end of this year, has got most of the things there covered, apart from things like super tins and maybe attributes on vertices and segments and things. But inside 12D, using the attribute manipulator, you can move vertex and segment attributes onto string attributes and then pull them back out again. So the attribute manipulator can allow you to get around a lot of these sorts of problems as well. But people who understand all of the above, plus latitude, longitude, heights, coordinate systems, map projections, and how to bring all that disparate data together, that's a big ask. I'm afraid for most BIM people at the moment tend to be from the architectural side where they don't worry about that at all. They just only work in their own little coordinate systems. So that's the one bit of learning that everybody needs to start coming up to speed on to bring these different coordinate systems and things together. You can't get away anymore with just 0, 0 in the left-hand corner of the building. So basically, yeah, horizontal BIM, open BIM, it can be civil. One way or another, we can get a lot of it through, but the things we're missing, which are tins, proper, and alignments, for most of it, there we are reading and writing them now in our alignment for version 14, and the standard will be out at the end of the year. But for people to understand all of that and all of the things, basically, it's you 12D surveyors and civil designers. BIM, open BIM and civil BIM needs you, because you're the ones who understand this and can point out to others that, hey, hang on, you've got to get the data correct for it to go across. So civil BIM needs all of you guys, not just leave it to the architects. Thank you.
Thanks, Lee. We've had quite a few questions through, so even though we're a little over time, I'll just read out a couple of these. Craig in Adelaide asked, does the global ID change for each IFC export?
This is an interesting thing, the global ID, and some packages use it as unique reference, but for that you then have to set it, and it doesn't change. The global ID can change. It's supposed to be unique in space and time. And that's one thing we're just having to look at, that for some packages you set it once and you have to keep it forevermore because they don't think the object changes. So 4.14, where I'm looking at, or it may come back into 12, is that we can potentially give things a global ID value. So it's there, and when we write it out, we use it. If it's not there, we create one at the time. The global ID, as you saw in that thing, is a horrible number. Horrible looking number, so to refer things by a global ID in civil, that's why we use string names and things. So at the moment we recalculate it every time we write it out, but we're realizing that some packages want that same number to go out. If the thing objects has changed, I don't know what really should happen then. But yeah, so at the moment we are create a new one when we write it out, because all of our data has a unique name.
Thanks for that answer there, Lee. Craig actually added something just now saying the reason for the question is for the repeatability of clash detection and the like in Navisworks. So I don't know if that gives you anything to add or if you'd like to take that offline with him later.
Yes, some of these packages have various ways of keeping track of data. And then that's why I say we'll probably just put a thing in there that we can say, give everything a global GUI, global ID, and if it's there, that's what we'll write out. But the question is, what happens when you say redo a road and basically every string changes? There's questions which that method that's very good where you've got one fixed chair and that chair never changes. The global ID is the only unique thing is great, but not very good for roads where every time you recalc a road, strings come and go. So to refer them to them by global ID, I think is a bit of a problem. But we're happy to talk to anybody about that because we know some packages are restricted there and have limits. And we'll try and find ways around it.
Sure. Scott in Sydney said, when writing out Trimesh, do you need to add an attribute manually for things like volumes and surface area?
That's where the global manipulator comes in and was demonstrated in Joel's webinar. You can have a good look at that because the global attribute manipulator allows you to do things like go and create an attribute for volume or area and all those sorts of things. So you can set up a global manipulator file so you can blast that through and give all the things you need. Because depending what the object is, you will need different attributes. Some of them make sense like that. Others could be 2D length, 3D length, and so on. So the attribute manipulator is there to allow you to do that. Because in most of these elements, they're just building proxy. You don't exactly know what they are, and you need to be told what attributes you want to go with them. So yes, it's easy to do. The attribute manipulator allows you to create string or trimesh or tin attributes for a lot of those properties. And then when you write them out, they'll go out to IFC property sets and be there at the other end. You just have to find out from the person who wants the data what they want those attributes to be called and exactly what they are. They might say length. Is it 2D length or a 3D length? You know, little questions like that.
Sure. I think we had a comment through from someone at in our New South Wales team here, I think in response to this, that just adds that those attributes are not needed for Solibri, but for Navisworks, that information isn't calculated. Do you have anything you want to add to that?
Again, this comes into different packages. I would say Solibri then probably works out some of those, if it can, from some of the objects you send it across, whereas Navisworks can't. So in that case, for Navisworks, you would run the attribute manipulator to put those properties on there beforehand. And that's where you have to know a little bit about the software package you're going into. One thing that you're all going to find this hard to believe, but when you put strings into Solibri, I think, Navisworks, Revit, and whatever, they have to have a diameter. They can't display strings without a diameter. So on our writer, there was a tick there to say, give the thing a diameter, which it's something, strings don't have to have a diameter in IFCs, but a lot of these packages are only working as though everything has to be like a physical object. So there are a few little tricks like that as well that you have to know about the packages you're going to. And say Navisworks, it looks like you have to pre-calculate some of these attributes, but the attribute manipulator will do it for you.
Thanks for that. One more very quick one. Chase in Queensland asked, when is V12C1M released?
Actually, I thought it was going to be released when I went to Paris, but it's actually up on the beta forum at the moment, release candidate 5. So hopefully in 6 days' time, it will become released as C1M. So it's basically imminent.
Perfect.
And at the same time, 12D View C1M, which I was running there to read in the data, because you mightn't realise that for the 12D View, the current version out there will read in 12DA and 12D XML data, but the 12D View 12 C1M, it will also read in IFC files and IFC zip files of 2x3. And so, as I say, they should all be out in the next week for you.
Thanks, Lee. And thanks to the audience for all your great questions. Sorry to those we couldn't get to live, but we'll get back to you individually by email. Our next two Industry Solutions webinars will be 12D Synergy and Abtract, a special presentation this Monday, the 9th of April, and Dynamic Culvert Designer also next week on the 11th of April. So register for those now if you haven't already, and keep an eye on our emails and social media channels for more great upcoming topics in this and our training series. If you need to contact us in the meantime, we'll pop some details up on the screen. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.